Hi, Math Stars. Today we will be working on this lesson 11 problem set, and just a super exciting day because we're finally graduating from just looking at these area models to finally look at these number lines and looking at fractions on number lines and using tape diagrams with those number lines just to visualize them. But it's pretty much the same thing we've been doing. We're going to look at the total number of pieces and then figure out the unit fraction and all of that good stuff. Okay? And if we remember from our lovely in-school class time that there's a number line in our room, a number line sibling just counts off. So this is a number line 1, 2, 3, 4, 5, 6, and we could obviously extend that to infinity. But today we're going to learn number lines and putting fractions in the number lines. So let's do 1A together. So let's get started. So it's asking us to label each number line with the fractions shown on the tape diagram. This is obviously the tape diagram. And circle a fraction that labels the point on the number line that also names the shaded part of the tape diagram. Okay, so first what they're telling us is that first they want us to pinpoint or put fractions on this number line, and then they want us to circle, okay, where on this number line is representative of this shaded part or this shaded piece. Okay, seems simple enough. Let's just start off by first naming our unit fraction because I think that'll just make it a lot easier for these problems. So how do we find our unit fractions again? Well, we know that it's just 1 over the total number of pieces. So what are the total number of pieces in this tape diagram? Well, let's count. 1, 2, 3, 4. There are 4 total pieces. So each unit fraction represents 1/4 or 1 over 4. And we're going to apply our same number line skills that we've known for such a long time into now our fractions. Okay, so a number line starts with 0, and this is telling us that this piece goes until 1. So we're going to end with 1. Okay, and it is safe to say that this piece is 1/4 or 1 over 4 because that's where this piece is cut off, and that's where we know this unit fraction is. And we can now just count. So if this is 1/4, we know that the next piece, the next step is 2/4 or 2 over 4. And then we know the next piece is 3 over 4. And then this next piece would be 4 over 4. And we know that if the numerator and the denominator are the exact same, that is just equal to 1. Okay, let's pay attention to this pattern we're seeing. So we're paying attention to the pattern of the denominator is staying the same as we count, but this numerator is changing. This numerator is just increasing by 1. Okay, so let's say I wanted to extend this just one piece. Do you guys have any idea where this, what would this piece represent in our number line? We have 1, 2, 3, 4, would represent 5, right? And then our denominator would stay the same. Another way we can see this is by adding. So we know that each unit fraction adds 1/4 or 1 over 4. So I could have done is 1/4 plus 1 over 4. We know that 1 plus 1 is 2. And when we add fractions, our denominator stays the same. So we get 2/4 and 2/4. If we wanted to add again, 2/4 plus 1/4. We know that 2 plus 1 is 3. Denominator stays the same, so that would be 4. And we got 3 over 4 and 3 over 4. Okay, so go ahead and try B and C on your own. So first step, remember, count the total number of pieces. then write the unit fraction, and then just count up. Your numerator should be changing. Your numerator should be going up, and your denominator, your number on the bottom, should be staying the same. Okay. And let's just look at 2a really quickly together. And it's asking us to write number sentences using multiplication to show the fraction represented in 1a is equivalent to the fraction represented in 1b. Okay, I am just going to set you up just because we didn't do 1b together. But we already know what to do. We're pretty good at multiplication. We're pretty good at these number sentences. So it's pretty much asking us to take our 1/4, which is represented, we're using 1/4 because that represents the shaded part. And it's going to try to get us to prove that 1a is equal to 1b. And really quickly, we can see that for b, the total number of pieces is 8 instead of 4. Okay, so what would happen if I multiplied the numerator and denominator by 2? I'm deciding to multiply by 2 because essentially what they did from 1a to 1b is they just cut each piece in half again. Okay, they just cut each piece in half again, which is why 4 pieces became 8 pieces. And then we know that 1 times 2, simple, that's 2. 4 times 2, let me just list my multiples really quickly to be sure I'm going to get 4 times 2 correctly. 1, 2, 3, 4. 4 times 2 is 8. So I can say that 1/4 or 1/4 is equal to 2/8 or 2/8. Okay? And then you're going to go ahead and apply that level of thinking to 2b. And then for 3a and 3b, all you're doing is the same thing we did, or you guys did for problem 1, but they just want you to draw your own number lines, okay? And you could get all fancy, you could use a ruler, or you could just go ahead and do your best straight line you can. Okay, great work, and I will talk to you guys tomorrow.